Okay, look at our question. We have sine inverse x plus cot inverse 1 by 2 equal to pi by 2, from which we need to find the value of x here. Okay, let's start. So, sine inverse x is there, plus cot inverse 1 by 2 is pi by 2. But there's a property we already know. Sine inverse x plus cos inverse x will surely be pi by 2. Okay, so this is what I want to bring here. Basically, we already have sine inverse x. We need to write this cot inverse 1 by 2 in terms of cos inverse. That's what we are looking for. Okay, so to get this, what do we do? To convert from cot inverse to cos inverse, to convert from one inverse trigonometric function to another, simply draw a triangle. Okay, so here we'll mark this angle theta. This will be cot inverse 1 by 2. Okay, how do you get cot theta equal to 1 by 2? 1 will be the adjacent side, 2 will be the opposite side. Okay, so what about the hypotenuse? It's root of the length of the hypotenuse will be root of 1 square plus 2 square, which is equal to root of 1 plus 4, and that comes out to 5 here. Okay, so we have root 5 as the length of the hypotenuse. Okay, so here what can you say about cos theta? Cos theta will be 1 by root 5. Since we are looking for theta, I can say theta is cos inverse 1 by root 5. Okay, so what happens to this equation? So this becomes sine inverse x as it is. Then cot inverse 1 by 2 will be written as cos inverse 1 by root 5. Okay, we already found that cot inverse 1 by 2 is cos inverse 1 by root 5, and this comes out to pi by 2. Now I have sine inverse of something plus cos inverse of something coming out to pi by 2. When does that happen? It happens when these somethings are the same. Basically, sine inverse x, that argument, and cos inverse x, these arguments should be the same. So here, how do we get pi by 2? When these arguments are the same. In other words, x is equal to 1 by root 5 itself. Put it back into the original equation. Let's see what happens. The first term becomes sine inverse 1 by root 5. The second term is already cos inverse 1 by root 5, and their sum is equal to pi by 2. So here we can conclude that the answer is x equal to 1 by root 5, which means option B will be the correct answer. Got that? Okay, in this question we have this expression cos of 2 cos inverse x plus sine inverse x. We have to find the value of this expression when x is given to be 1 by 5. Okay, let's start. So, x is equal to 1 by 5 is already given to me, and this is what we need to find. Now, here inside this y equal to cos of 2 cos inverse x, I will write that as cos inverse x plus cos inverse x. Alright, cos inverse x plus cos inverse x is what happens here. And then comes the other sine inverse x. Why are we doing this? Because we already know that sine inverse x plus cos inverse x will be equal to pi by 2. Just make sure that x is between -1 and 1. Okay, so x is 1 by 5. For our case, we are sorted. So we'll replace cos inverse x plus sine inverse x as pi by 2. Alright, so then this becomes y equal to cos of cos inverse x plus pi by 2. Okay, so we have something here in the form of cos of theta plus pi by 2, where theta is cos inverse x. Or in other words, cos theta is x. Okay, so here we have theta equal to cos inverse x. We have cos of theta plus pi by 2. This is nothing but, look, pi by 2 is here. So cos becomes sine. And we are looking at the second quadrant where cos is negative. That's why I put minus here. This becomes minus sine theta. And what was theta? Cos inverse x. Okay. So basically, we get y, the value of y, as minus sine of cos inverse x. Okay, so sine of cos inverse x is what we have, and we already know a property that sine of sine inverse x, where x is between -1 and 1, goes without saying, is equal to x itself. All right. So here, what do? We need to convert this cos inverse x into some sine inverse term. Okay. So cos inverse should be converted to sine inverse. How would we go about doing this? Draw a triangle. All right. So we have cos inverse x here. Cos inverse x means cos of this angle theta. Okay, this angle is what I'll call theta. Cos theta is equal to x, and x in our case is 1 by 5. Okay, so cos theta is 1 by 5. So it means adjacent side, which will be 1 unit length, and divided by hypotenuse, which will be 5 units in length. Can you tell me about the third side? Use Pythagoras theorem. So the third side here becomes root of 5 square minus 1 square. 5 square is 25, 1 square is 1. This simply comes out to root 24. Okay, so we have the third side in our Pythagoras. We have the third side by Pythagoras theorem in our right angle as root 24. Okay, so then here this becomes sine inverse. Sine inverse of what? How do you get sine theta? Root 24 by 5. Directly bring that in. Okay, we are sorted. We have our answer here. Okay, this comes out to minus of root 24 by 5. How did that happen? Sine of sine inverse x is equal to x as long as mod x is less than or equal to 1. Okay, so with this we get that y is equal to minus root 24 by 5, which will be my final answer, option C here. Okay, so if you notice, minus root 24 by 5 is option C. And in this question, what did we do? Cos inverse x plus sine inverse x, we took it as pi by 2. And this became cos inverse x plus pi by 2, cos of cos inverse x plus pi by 2, which further became minus sine of cos inverse x. What is your next task? Convert cos inverse x in terms of sine inverse. Because sine of sine inverse of anything is that same anything. Got that? Okay, look at our question. Here we are simply asking for the values of x, satisfying this given expression. Tan inverse 2x plus tan inverse 3x equal to pi by 4. Let's start. So here we have tan inverse 2x plus tan inverse 3x equal to pi by 4. Now, on the LHS, I see a tan inverse x plus tan inverse y, or rather tan inverse a plus tan inverse b forming there. Okay, so how do you take care of tan inverse a plus tan inverse b? You have two options. If a into b is less than 1, then the sum is tan inverse a plus b by 1 minus ab. Okay, if the product ab is greater than 1, then it will be pi plus tan inverse a plus b by 1 minus ab. Okay, so with this information, we will be moving forward. Now, look at the first part here. Tan inverse a plus b by 1 minus ab, tan inverse whatever. Okay, we know that tan inverse of anything is between minus pi by 2 and plus pi by 2. Agreed? Okay. Now, what about the second part? Second part is pi plus a quantity between minus pi by 2 and plus pi by 2. So it goes between minus pi by 2 plus pi, comma, pi by 2 plus pi. Pi is added to both the lower and the upper end. Okay, lower and the upper bound. Okay, so then this becomes plus pi by 2, comma, 3 pi by 2. Okay, so we have tan inverse A plus tan inverse B here in this form. Okay. Now, we have the RHS in the question given to us as pi by 4. Which of these options will you pick? There are two cases here, AB less than 1, AB greater than 1. Okay, which of these options will you pick? So pi by 4, all right, is clearly between minus pi by 2 and plus pi by 2 as per the first option. As per the second option, pi by 4 is not within pi by 2 and 3 pi by 2. So the second option is not possible. So in other words, the product, so the inference I get out of this is that the product here, A into B, is certainly, definitely less than 1. Okay, so A into B is 2x into 3x, and this is given to me as less than 1. In other words, x square is less than 1 by 6. So what can you say about the values of x? That x is between minus 1 by 6 and 1 by root 6 and plus 1 by root 6. Okay, we have x between minus 1 by root 6 plus 1 by root 6. We'll keep it there for now. Okay, now what happens to this sum? Tan inverse 2x plus tan inverse 3x. We are going for the first case where AB is less than 1. If AB is less than 1, we get that x is between minus 1 by root 6 plus 1 by root 6. Now for the other part, we have to take care of this summation, right? So let's do that. This becomes, so this entire, the question, the LHS of the question becomes tan inverse a plus b by 1 minus ab. That becomes 2x plus 3x by 1 minus 2x into 3x. Okay, this is this sum on the LHS, and the RHS remains as it is, pi by 4. The next step involves taking tan on both sides. That's it. Okay, so then this becomes tan of tan inverse 5x by 1 minus 6x square, and this is equal to tan of pi by 4. We are just taking tan on both ends here, and then let's see what happens. Tan pi by 4 we know is 1. And what about the LHS? Tan of tan inverse A is A itself. Okay, now let's put that value here. 5x by 1 minus 6x square. So when we rearrange this, we get 5x equal to 1 minus 6x square. Or in other words, we get 6x square plus 5x minus 1 equal to 0 as our first condition, and x between minus 1 by root 6 and plus 1 by root 6 to be our second condition. Both should be satisfied at the same time. This is what we have obtained till now. Let's proceed. Okay, so here we can see that we have two conditions given to us now. One is x square less than 1 by 6. In other words, x between minus 1 by root 6 and plus 1 by root 6. This is where x will lie. Okay, what about this here? 6x square plus 5x minus 1 equal to 0. Clearly, b square minus 4ac is greater than 0. You can factorize this into two parts like this. 6x minus 1 into x plus 1 equal to 0. And we have x between minus 1 by root 6 and plus 1 by root 6. So this tells me that x can be either 1 by 6 or minus 1. Okay, now here it's given that x should be between minus 1 by root 6 and plus 1 by root 6. Alright, that is why this information is critical. We can simply remove x equal to minus 1. Okay, because it's not between minus 1 by root 6 plus 1 by root 6. What about 1 by 6? Yes, it is. Okay, this is perfectly valid. So, my solution will be x equal to 1 by 6. As simple as that. That's it. The problem is solved here. Okay, so there is only one solution, and that will be our conclusion here. Option B is the correct answer. What did we do in this question? We looked at the LHS. Tan inverse A plus tan inverse B form is what I found. Okay, so how do I find the summation here? There are two cases. I find out that because of the RHS, the value of the RHS is pi by 4, we are looking at the first of those two cases. Okay, so it will directly be tan inverse A plus B by 1 minus AB. Once we get there, I apply tan on both sides, and then RHS becomes tan pi by 4, in other words 1. From there, I get the quadratic, and also since I applied that first property of tan inverse x plus tan inverse y, I also get that tan inverse A into tan inverse B, I also get that A into B will be less than 1. So from there, I get that x is between minus 1 by root 6 and plus 1 by root 6. Okay, so this is what we obtain. So there was a quadratic on the side, we solve it, we get two solutions, but only one of them lies in this domain. Okay, between minus 1 by root 6 and plus 1 by root 6. So that's how we arrive at B as the right answer. Got that? Okay, look at our question. K is a real number such that tan of tan inverse 2 plus tan inverse 20k is equal to k itself. All right, then the number of all possible, or rather the sum of all possible values of k is what we are going for. Let's start. Okay, so here we have our question with us. Now it's tan of tan inverse 2 plus tan inverse 20k. Okay, so I will treat tan inverse 2 as some angle A and tan inverse 20k as some other angle B here. Okay, so basically what I can say from here is that, so tan A is 2 and tan B is 20k. Okay, this information is good for us because we will be modifying the question here as tan of A plus B being equal to k. We already have the formula for tan of A plus B, right? We are sorted. So let's apply that. This becomes tan of A plus tan of B divided by 1 minus tan A into tan B equal to k. What's tan A? Tan A is 2. Tan B is 20k. 1 minus tan A into tan B becomes 1 minus 40k. Okay, and this value, guys, is equal to k itself. Okay, we brought in the RHS here. Now, what is our next step? Rearrange. Okay, let's start solving now. So here, 2 plus 20k equal to k minus 40k square. Okay, so let's rearrange this whole equation. This becomes 40k square minus, or rather plus 19k plus 2 equal to 0. Okay, so here I get this quadratic in k. 40k square plus 19k plus 2 equal to 0. Okay, now how would we proceed? We have this quadratic. What are we looking for? We are looking for the sum of all values of k. Okay, so this quadratic, first thing, check, are the roots real? Does a real value of k exist? Okay, so to check for the roots to be real, we check if the discriminant is positive. Okay, we check for the value of the discriminant. So d is b square, 19 square, minus 4ac. 19 square is 361, minus 4ac, 4 into 40 into 2 is 320. No need to calculate, we just know that it's greater than 0. K will be real. What do we need to find? The sum of all values of k. K is the root. K represents the roots of this quadratic equation. Okay, so the sum of all values of k is given by minus b by a. This is true for any quadratic equation. So then this becomes minus 19 by 40. So which means k1 plus k2, the two roots, the two possible values of k, will come out to minus 19 by 40. Let's mark option A as the correct answer. What did we do in this question? I took this tan inverse 2, called it angle A. I took tan inverse 20k, called it angle B. From there, it's just expanding tan of A plus B and putting the values, making that equation in terms of k, and then solving for the quadratic. That's all we did, and we arrive at the answer, or rather the sum of the roots, sum of the values of k, to be minus 19 by 40. Got that? Alright, look at our problem here. We have cos inverse 2 by 3x plus cos inverse 3 by 4x equal to pi by 2. Okay? Now, it's also given to me that x is greater than 3 by 4. We need to find the value of x here. Okay? So, first thing I'll do is I'll take one of these terms. There are two cos inverse terms on the LHS. I'll take one of them to the RHS. Okay, so from there I'll get cos inverse 2 by 3x equal to pi by 2 minus cos inverse 3 by 4x. Now, pi by 2 minus cos inverse A is equal to sine inverse A. So, in our case, A is 3 by 4x. Okay, so basically we end up with cos inverse 2 by 3x equal to sine inverse 3 by 4x. Now, what can be the possible next step? Look at that sine inverse 3 by 4x. Convert that to cos inverse term. Okay, so this should be written as some cos inverse term. Okay, so how do we convert sine inverse to cos inverse? Other than by adding pi by 2, like from subtracting from pi by 2. How do I convert sine inverse to cos inverse? I draw a triangle, a right angle triangle, such that sine of theta, okay, the angle represented by sine inverse 3 by 4x is theta. Okay, so then what is sine theta? It will be opposite side by hypotenuse. So I'll write that as 3 by 4x. Now this is perfectly valid because I already know that x is greater than 3 by 4, which means x is positive. So 4x is positive, 3 is also positive. Okay, what about this third side here? The third side, use Pythagoras theorem, you will get 16x square, or rather 4x the whole square minus 3 square. So you get 16x square minus 9. So now let's convert this to cos inverse. This becomes cos inverse root of 16x square minus 9 divided by 4x. I can also write that as cos inverse root of 1 minus 9 by 16x square. Okay, we have arrived somewhere right now. Okay, so we have cos inverse 2 by 3 equal to cos inverse root of 1 minus 9 by 16x square. What does it mean? You can equate both the arguments together. Okay, so both these arguments you will have to equate. Okay, so it becomes 2 by 3x equal to root of 1 minus 9 by 16x square. Okay, let's square both the sides. Let's see. This becomes 4 by 9x square equal to 1 minus 9 by 16x square. We leave it there and then continue. Okay, so from now we are almost at finding x. Okay, let's solve that. Okay, so here we can see that 4 by 9x square equal to 1 minus 9 by 16x square. Multiply throughout by x square. What happens? This becomes 4 by 9 equal to x square minus 9 by 16. In other words, x square equal to 4 by 9 plus 9 by 16. What does this come out to, guys? 9 into 16 is 144 in the denominator, and the numerator 4 into 16 is 64. 9 into 9 is 81. And you add them up, it becomes 145. Denominator is 144. We have the value of x square here. Now, x is, so we have x square as 145 by 144. What is the value of x? X will be plus or minus root of 145 divided by root of 144, which is 12. Okay, so we have x equal to plus or minus root 145 by 12. So one or more answers might be correct. We will be marking both of them as the right answer. No, not yet. Why? Because x, it's given to me as greater than 3 by 4. Okay, x is greater than 3 by 4. Now here 145 by 144 is greater than 1. So its square root will also be greater than 1. The magnitude of the square root will also be greater than 1. So this plus or minus is there. So only one of these we check, right? So x will be root of 145 by 12. Okay, so since x is greater than 3 by 4, we conclude that only one of them is correct, and that is x equal to root 145 by 12, which means option A will be a correct answer. Got that?